further than the previous point. When the paper point comes back showing red, you've gone past the apex. Pluggers are fitted into the canal space in succession. In this animated example, the large plugger reaches a few millimeters into the canal space. A smaller plugger goes several millimeters further to mid-root in this example. The smallest plugger should get within 5 millimeters of the working length. A gutta percha cone is selected to closely match the canal space. The cone is inserted to length. The appropriate cone should bind slightly at the apex and exhibit a slight tugback when removed. Here, about a millimeter is clipped off of the apical end of the cone. It is then coated in sealer and reinserted into the canal space. The sealer adheres to the canal walls as the cone is worked back and forth. A thin coat of sealer is desirable for these techniques, so in this animated example, we remove the cone to show that there is still some sealer on the cone as well as the coating that is left on the canal walls. The cone is reinserted to length. A heated instrument is used to remove the excess gutta percha. Downpacking begins with the largest plugger. It is worked around the orifice. It is then pressed into the gutta percha mass and held for about 5 seconds and then removed. In a traditional vertical condensation downpack technique, the heat carrier is inserted into the gutta percha mass a few millimeters. The change in color indicates that heat is being transferred a few millimeters down through the mass of gutta percha. The heat is then turned off and the instrument is removed. Some gutta percha will stick to the cooling instrument as it is removed. A pre-fitted plugger is introduced to compress the gutta percha that has remained in the canal space. This plugger is worked around the canal to push the gutta percha down and compress it into nearby lateral canals and anastomoses. The plugger is then held on top of the gutta percha mass for about 5 seconds as it cools. This helps to minimize shrinkage. The heat carrier is again inserted. It is taken a few millimeters deeper into the gutta percha mass. As the power is turned off, the heat carrier is removed and another ball of thermosoftened gutta percha adheres to the instrument. Again, a pre-fitted plugger is inserted to circumferentially compact the remaining gutta percha. In this animated example, the plugger pushes the gutta percha within 5 or 6 millimeters of the apex. The plugger is again held against the gutta percha mass as it cools. The plugger is then removed, showing a completed downpack obtained with the vertical condensation technique, which is ready for backfilling. In a continuous wave downpack technique, the heat carrier is inserted into the gutta percha mass. Color changes indicate where the gutta percha is changing temperature and being thermosoftened. The heat is kept on as the carrier is pressed further and further into the gutta percha mass. As the carrier moves apically, gutta percha is forced laterally into canal irregularities. Deep in the canal space, the heat is cycled off. Downward pressure is kept on the cooling carrier. This continued pressure in turn exerts pressure on the gutta percha, forcing it into more lateral canals and anastomoses. After several seconds, and when the carrier has reached its ultimate depth, a second 1-second burst of heat is applied. 1 second later, as the carrier begins cooling, it is rocked side to side in the canal space. This motion separates the gutta percha mass into a segment apical to the heat carrier tip and a segment coronal to the tip. The carrier is then removed from the canal space. The apical portion of the separated gutta percha mass remains in the canal space. The rest of the gutta percha comes out of the canal space with the carrier. A small pre-fit plugger is inserted into the canal space and used to tamp down the apical plug of gutta percha. The plugger is removed in the final step of the continuous wave technique, leaving the apical plug and the remaining space ready for backfilling. In a hybrid downpack technique, the heat carrier is cycled on and off as it is inserted into the gutta percha mass. Initially, the hot carrier is inserted into the gutta percha mass several millimeters. Changes in the gutta percha color indicate where the material is being heated and softened. In this animated example, the carrier goes about 1/3 of the way down into the canal space. The heat is turned off while pressure is still being applied to the carrier. This forces gutta percha and sealer into canal irregularities in the coronal portion of the canal space. This cooling period pressure lasts about 5 seconds. The heat is then reapplied to the carrier and the instrument is forced several millimeters deeper into the canal space. The thermo-softening action, combined with the downward pressure, forces filling materials into lateral canals and other anastomoses in the mid-root region. Apical pressure continues to be applied to the carrier as the heat is again turned off. In this animated example, the carrier reaches within 5 millimeters of the apex during this 5-second long cooling and compression phase. A final 1-second burst of heat is applied to the carrier. A second later, as the instrument cools, it is rocked side to side to separate the gutta percha into 2 segments, one apical to the tip of the carrier and one coronal to the carrier tip. The cooling carrier is then removed from the canal space, leaving the apical plug. The coronal mass of gutta percha comes out of the canal space with the carrier. A small pre-fit plugger is inserted into the canal space and used to tamp down the apical plug of gutta percha. The plugger is removed in the final step of the hybrid technique, leaving the apical plug and the remaining space ready for backfilling. Upon completion of the downpack of the canal, the backfill can be accomplished coronally up to the pulp chamber or to a shorter point if a post is prescribed. With the B-fill device loaded and hot, insert the needle into the canal space down to the previously packed filling material. Press and hold the activation cuff on the handpiece to begin the flow of gutta percha. Allow the flow to gently push the handpiece a few millimeters coronally. Release the activation cuff to stop the flow. Remove the B-fill handpiece and use a small pre-fit plugger to compact and adapt the material. Reinsert the B-fill needle into the canal space against the compacted material. Again, press and hold the activation cuff to restart the flow until a few more millimeters of the canal has been filled. Release the activation cuff to stop the flow. Remove the needle and use another plugger to condense the material. Repeat this process until the canal is filled to the desired level.